Hello everyone, and welcome back to another GIS statistics tutorial video. And in this video, I want to talk about something a little bit different from before. I want to talk about a way that we can sort of statistically test for statistical significance in these GStat, KStat, and LStat. Right, because we have some values, we have some graphs, right? We can interpret those graphs, but how do we determine if the thing that we're actually interpreting is statistically significant, right? Because that's kind of a big question in statistics, right? Does this thing that we think we see actually matter? And the most common way to do that is through what's called the maximum absolute deviation test, or the MAD test. I will say this because I actually got tripped up by this. Depending on which version of SpatStat you're using, it could either be test.mad or mad.test. They've recently updated the package and they've changed the arrangement of those two words. So if test.mad does not work for you, then try mad.test. So let's go ahead and just quickly look. This version of SpatStat that I have installed on this computer is actually going to use the mad.test. So SpatStat : mad.test. And so if we go up here, you'll see that there are two different tests. We want the MAD test. And just like before, this takes in as an object the data set that we want to test against. So this is the data set that we're curious about. One of the things that is not listed in here is the FUN argument, which is basically what statistic do you want to test against. So what I want to do here is I want to walk through an example of each. And what I want to do really quickly is just scroll up to some previous code that we've written. If you haven't watched the videos where we generated GStat, KStat, and LStat, I would encourage you to go back and watch those, because we're actually going to use those concepts in this video here. So what I want to do is I want to run the MAD test 3 different times. I'm going to call mad_G, where we're going to test the G significance. And so again, we're going to, well, before we do anything, right, as always, we have to make sure that our data is sound. So we're going to call in the New Haven data set. We are going to convert that breaches data set, which is the data set that I've been using in all these examples. Right, again, this code is not strictly necessary. This is just to show you that I'm using the breach variable and making sure that it exists. The big thing with all of the SpatStat functions is that they require the as.ppp conversion. So we will call breach_ppp equal to SpatStat, because this is coming from the SpatStat function, or sorry, this is coming from the SpatStat package as.ppp, which takes in as its parameter the data that we want to convert. Okay. Now we have to run the MAD test. So we're going to use the G statistic first. So in this version, it is mad.test. Again, coming from SpatStat package. The critical thing here, again, depending on what version of SpatStat you have installed, older versions of SpatStat have test.mad. Newer versions of SpatStat have mad.test. So if this code as written doesn't work for you, if it says that no mad.test namespace, right, if you get this error, is not exported object from namespace, then flip it and try test.mad. One of those two should hopefully work for you. So what mad.test takes in is it takes in this capital X, which is the data set. So we want the breach_ppp object. And then it also takes in the function or fun argument, which is what test, what statistic do you want to test this with? And we want to test GE, we want to test SPAT-STAT, : the G statistic. Then there's one other parameter called NSIM. So again, MAD test is a simulation approach. So basically, number of simulations is going to be how many times is it going to run this thing before giving us a comparison. The default, I believe, is 100. I like to run 1,000. I just feel it's a little bit more robust. And it doesn't take that long to compute on most modern computers. So if we run this, you'll see that it's calculating it. It's going to do this 1,000 times. It's going to say done. So now if we type in mad_g, what we're going to get out of this is the results. So this is just saying that we ran the maximum absolute deviation test, and we're testing for complete spatial randomness. It's saying that we did 1,000 simulations of Monte Carlo. Again, this is not super important that you understand this. The summary function, this is saying we tested the G statistic. And then down here, this is where we're actually looking for. We're looking for MAD, this is the test statistic, and then we're looking here for the p-value. Now, the alternative hypothesis, or I should say the null hypothesis, the null hypothesis in this case of the MAD is that our data does not statistically significantly different from expected. Right, let me restate that. The null hypothesis of MAD is that our data is not different from expected. So when our p-value is below whatever our threshold is, it means that our data is statistically significantly different. Right, we can reject the null hypothesis, which basically means that we do actually see some sort of deviation from expected. And you would go back in, you would look at the plot to figure out whether you are, for the distances you're looking at, whether you are clustered or dispersed. So let's look at one more example. That was the G. Let's look at the L. So we're going to call MAD L. Same sort of thing. We're going to call SPAT-STAT : mad.test. And again, depending on what version of SPAT-STAT you have installed, it may be test.mad. We're going to call in the same data set, breach PPP. But now we're going to pass in the function of SPAT-STAT, the lest function, because we're going to be testing the L statistic. And again, we want to have 1,000 simulations. So we're going to run that. It's going to take just a second. Okay. So now what we're going to do is we're going to type in mad_L just to sort of investigate here. And you'll see again, same thing, maximum absolute deviation test, 1,000 simulations of Monte Carlo. And then down here, you have your MAD statistic, and then you have your p-value. And this p-value again is going to indicate whether or not your data, you can reject the null hypothesis. And the null hypothesis is that your data is not different from expected. So this means that we do, in fact, likely deviate from random. So this means that there is some sort of a pattern to our data, and you would have to go look at the values of L and look at the plot to figure out which direction you're going. Hopefully that makes sense. And as always, please reach out. Thank you.